Hello, class. So we have to do a very quick review of the metric system and what part of the metric system that you're going to be responsible for AP Physics. Not the biggest section of the metric system. You will have to know about your base units, specifically meters and grams, seconds. There'll be a bunch of other metric or SI units that we'll deal with over the year. And you have to be able to convert through the common prefixes and multipliers. So up here you have obviously the base unit. 1,000 base units is a kilo, kilometer, kilogram. 1,000,000 base units would be a mega, megagram, megameter. If we get to smaller divisions, one base unit is equal to 100 divisions, centimeter, centigram, milli, micro, 1,000,000. The symbol is that mu symbol. It's a little Greek letter. It looks like a little U with a tail. And then if you get really small, a billionth of something, it's nano. Some books won't write it this way. Some books will write it as how much of a base unit these smaller divisions are worth. For instance, they'll say that a centi is worth 0.01 base units. That's a centi. That a milli is 0.001 base units. And so forth. And so forth. Now, some textbooks, they won't even write the numbers fully. They'll write these as powers of 10. Because that's the whole thing about the metric system, right? It's all based on powers of 10. So instead of 1,000,000, they're going to write the equivalent. They're going to say, well, it's 10 to the 6th. A kilo, they're going to write 10 to the 3rd. A centi, which is 1/100th, well, 1/100th would be 10 to the -2. 10 to the -3. 10 to the -6. That's a terrible 6. There we go. And 10 to the -9. So they all really say the same thing. Which way works better for you? I don't know. Pick a way, but you have to know these. You have to memorize them, and we're going to have to be able to convert from one unit to the next, and we'll get into that in a little bit. Thanks. Very, very brief mention of the SI system of units, which is the International System of Units. And originally, when it was made in French, it was Système International, and I don't have a good French accent, so sorry, not sorry. This is actually a copy of the published, part of the published conference that happened in 1960 in Paris, when all the scientists in the world, or a good portion of scientists in the world, got together, and they acknowledged, they had acknowledged this previously, but they had re-acknowledged that all scientists should use common sets of measurements so that one scientist in one part of the world could understand the data from another scientist in another part of the world, because they were using the same measuring systems. Now, the International System of Units is based off of metric, and it almost matches perfectly across all measurements. There's a few exceptions. The one exception is mass. The length measurement in the SI system is a meter. The metric system, the base unit, is a meter. Time, SI and metric both use a second. But in mass, the base unit for mass is a gram, which is small. It's pretty teeny. The SI unit for mass is a kilogram. And a kilogram is 1,000 grams, about 2.2 pounds, which seems kind of heavy, but given the nature of the universe and the mass of planets and suns, and then you go down to the level of atoms, the kilogram's a better middle ground, amongst other things. So that's really, in our class, the difference between the two systems. We are going to use the SI system in class, where kilograms is the measurement of choice, versus the metric system, where grams is the base unit. Thanks. So a couple other units that are going to be useful in the beginning of this class are some imperial or British units for length. 5,280 feet a mile, 1 foot is 12 inches, and converting seconds to other times, 60 seconds in a minute and then 60 minutes in an hour. We might need to convert from hours to seconds, or go from miles to meters, and we're going to have to use some of these other conversions as possible mid-steps. Okay? Some other just quick conversions we're going to be using in the first couple chapters is some length and mass conversions. We have 2.54 centimeters equals 1 inch. That might be useful at home if you're measuring stuff and you only have an English ruler or a British ruler, and you do not have a metric ruler or with that. 1.61 roughly kilometers is equal to a mile, and 2.2 kilograms is roughly a pound. The other thing I forgot to put up here is that 28 grams is roughly one ounce. This actually doesn't compare the same thing. One is mass and one is weight, but we'll get into that discussion a little bit down the line. So, but it's good enough for now to get you to convert from one thing to another if you need to when you're at home. So, correction, I said 28 grams per ounce. It's 28.3 grams roughly per ounce. Sorry about that.